Hey SM3, this week we're going to be covering 3.2, adding, subtracting, and multiplying polynomials. So, a lot of this stuff should actually be something that you should already be quite familiar with and used to, especially adding and subtracting. So I've broken this down into 5 parts, this lesson. So, first part is engagement, where I want you guys to engage in some previous knowledge that you've already had. So, think back to what you've learned in secondary mathematics 2, and what we've already been learning. But let's see if we can add and subtract these polynomials. So, adding and subtracting is really easy because all it really is combining like terms, right? So, especially whenever you're adding. Whenever you're adding, these are just two polynomials. This is 1, this is 2, and we're adding them together. So all we have to do is combine the like terms. So in this polynomial, there's an x squared, and over here is an x squared. These are like terms because these are terms that have the same variable, x, and x, and then the same degree. X is being squared. While on the other hand, this is a like variable with this variable because again it's the same variable x and to the same power of 1. And then constants are of course also like variables, like terms. So just combine the like terms. So here and here. When I say combine, it just means you're going to combine the coefficients, right? So if we have negative 4 and negative 1x, if we combine those, that's going to be negative 5. So negative 5x squared. Okay, so we combine those. Now we can combine these right here. So negative 6x plus 7x would be 1x. Plus 1x. So those are gone. And then 18 and 8. So that should be 26. There you go. It's as simple as that. Now, subtraction is a little bit different, right? You always have to remember that whenever you have a subtraction sign, a negative sign outside your parentheses, that the negative has to be distributed. So that has to distribute throughout here, which actually means it's going to change the signs of each term. That is inside. So let's go ahead and do that. So before we combine like terms, so this is 6x squared minus 12x plus 48. Now I'm going to subtract a negative, which is actually a positive, so it's going to be plus x squared. Subtract a positive, which is still subtraction, so that's minus 24x. Subtract a negative 63, which is adding 63. Okay? Now we can combine like terms. So here and here, so that's 7x squared, 12x, negative 12x, and negative 24x, so that's negative 36x. Okay, and then we have 48 and 63, that should be 11, that's 15, that's 16, 161 I think. Make sure you check my math, guys, make sure I'm not doing this wrong. I might be, but anyways, that's how you would do it. So go ahead, you guys can pause the video for a second and you can try number 3. But I'm going to keep moving on because this should all be something you're familiar with. You should also be familiar with how to multiply two polynomials, okay? In SM2, you should have been introduced to 3 methods. There was a FOIL method, there was a table method, and a distribution method. Now, the table method is really intuitive, but it takes up space and time. So, I'll show you how to use the FOIL method on the first one, and then distributed method on the second one, but basically what it means to multiply two polynomials is that you take every term from one polynomial, so in this case we would take the 2x and the negative 4, and we'd have to multiply those with these terms inside here. So again, the methods help you do that. So if you guys remember the FOIL method, FOIL was an acronym. So the F in FOIL meant your first terms. So that means you would multiply your first terms together. So the first term in both polynomials. So that term and that term. So that'd be 2x times by 3x. Well, that just equals 6x squared. Okay, now O was the outer terms. So that would be the first term in this binomial and the last term in this binomial. So those are the outer terms. So 2x times by 3, which would be 6x. Then the I in FOIL was the inner terms, which would be this one and this one right here. So negative 4 times by 3x. And that was negative 12x. And then the last terms, which was just the last terms in both of them. So that's negative 4 times by 3. So you see what we did here is we took every term from this binomial and multiplied it with every term in this binomial. So that's negative 12. Now we just have to add these together. So we have 6x squared plus 6x minus 12x minus 12. And then we can combine the middle two terms because those are both terms of x variable to the first power. So 6x squared negative 12x and positive 6 would be negative 6x minus 12. So that would be the end result. So the thing about using the FOIL method is that it only works whenever you're multiplying two binomials together. We can't really use the FOIL method in this other example because here we have a trinomial. But in any case, I like to use the distribution method most of the time because most of the time I can just see it in my head. But the distribution method works like this. So I'm going to take both terms right here, this 6x and negative 1, and I'm going to multiply it by this polynomial. So that means, again, that I'm going to multiply every term from one polynomial with every term in the other polynomial. So this is how the distribution method looks. So I take 6x, and I'm going to multiply it by x squared plus 4x plus 1. And then I'm going to take my other term, negative 1, and do the same. X squared plus 4x plus 1. And it's called distributed method because now we just distribute both terms inside the parentheses. So for the first one, it's 6x times x squared. That's going to be 6x squared. Actually, it's going to be 6x cubed. Sorry about that. Because that's x squared times x, so that's x cubed. Now 6x plus 4 times by positive 4x, that's plus 24x squared. And 6x plus 1, which would be 6x. Now we go to the next side. So we have negative 1 and multiply it by x squared, that's negative x squared. Negative 1 times 4x is negative 4x. Negative 1 times positive 1 is negative 1. So now all that's left for us to do is combine like terms that are being added and subtracted here. This is the only term that has an x to the third power, so I can't combine that with anything. Now I have 24x squared and this negative x squared, so that should be plus 23x squared. I have this 6x and this negative 4x, which is positive 2x, and then negative 1. So that's the distributed method, and that's the one I usually like to use. I think it's the most efficient, I think it's the most effective as well, most accurate. I mean, they're all accurate. You get the same answer, right? It's just a matter of how much time you spend on it, how easy it is to do, but I think this one's really good. So hopefully we freshened up a little bit on your previous knowledge. So let's try and expand on that and explore some new ideas. So again, these might be things that you're familiar with, but we're going to look for some patterns. Okay, so the first pattern we want to look at is a plus b times by a minus b. So we're going to be multiplying binomials. So in this case, notice that the terms here are the same. They're both a and b. What isn't the same in this specific example is the operation inside. One's being added, one's being subtracted. So let's see what happens when we multiply these together. So if we multiply, we can use any method of choice. So if we're squaring binomials, if we're multiplying two binomials together, then we can use the FOIL method or distributive method, so whichever one you like. So if I were to multiply this out, I would take this a and multiply it by both terms in the other one. So that's a times a, which is a squared, a times negative b, which is negative ab. Now I take the second term, and again I multiply it by both terms in the other binomial. So that's b and a. So b times a is positive ba. And then I have b and negative b, which is negative b squared. Now, can we combine any like terms? So you might say no, but these terms are actually the same. Because a and b are being multiplied, these are actually the same, because 3 times 15, if we did 3 times 5, this is the same thing as 5 times 3, correct? It's because this is multiplication, and in our case, multiplication is commutative, which means that we can arrange the order of the terms being multiplied and still get the same answer. So these are actually the same terms right here. So this is actually equal to negative ab, positive ab. These actually cancel out, so we're left with a squared minus b squared. Okay? So notice the pattern here is that whenever you multiply two terms together, two binomials together, and the terms are the same, and the operation inside them is different, your answer should look like this. So as an example, let's say we had x plus 3 times by x minus 3. Well, guess what? We already did this process, so we can just plug in our terms right here. So now we know that the result should look like x squared minus 3 squared, which is equal to x squared minus 9. So we just found a pattern, so now we can avoid doing all of this right here of multiplying it out, because we know that there is a pattern. Okay, let's try another example of a plus b squared. A plus b squared. So this is another special product that does have a pattern. Let's see if we can find it. A plus b squared is the same thing as a plus b times by a plus b. Okay? So, let's multiply these together. A times a is a squared. A times b is ab. B times a is ba. B times b is b squared. Now again, these are like terms, so we can combine them. So that's a squared. That's going to be 1ab plus another ab, which would be 2ab plus b squared. Okay, so now we have another pattern right here. We have a squared plus 2ab plus b squared. So let's try another example. So if we take, for example, x plus 3, and that's being squared, well, let's skip right to this point and just plug in what we have. So a squared, a in this case is x, right? So x squared plus 2 times by x. B in this case is 3 plus 3 squared. Now we can simplify this, so this is x squared plus, now again, for this term right here, we can multiply the 2 and the 3 together, so that's 6x because this is 2 times x times 3, so we can multiply the 2 and the 3. And then the last term would just be 9, right there. So there you go. We found a pattern. Okay. Now we could try a minus b squared, which again, if this is being squared, this is equivalent to a minus b times by a minus b. So a times a is a squared times by negative b is minus ab. Negative b times by a is minus ba. Negative b times negative b is positive b squared. Combine these middle terms, see how they're both negative this time, so that's equal to a squared minus 2ab plus b squared. So you see how similar this is to this one right here. So if we take an example, let's say we have x minus 3 squared. Let's plug in our values of x and 3, so this is x squared minus 2 times by a, which is x, b, which is 3, plus 3 squared. Simplify, x squared minus 6x plus 9. So you see the only difference between this one right here and this one right here is that this is subtraction, this is addition. So, there you go, we're finding some patterns, right? Now, this is squaring. See how we squared this binomial and squared this binomial? What happens if we were to cube the binomials? So let's try this for a plus b. Let's say we cubed that binomial. Well, that's equivalent to a plus b times by a plus b times by a plus b. Okay, so here's the thing though. We already solved for this right here, right? We just solved for that just up here. A plus b squared is a squared is this right here. So I'm going to go ahead and write that in its place down here. So that's equivalent to a squared plus 2ab plus b squared, and we're multiplying it by a plus b. So if I were to multiply that out, I take this term and multiply it by both terms inside. So that's a cubed plus a squared b Alright, now take the middle term, multiply it by both terms, so that's 2ab times by a, which is plus 2a squared b, and now multiply 2ab times by b, which is plus 2ab squared. Now this term right here, b squared times a is b squared a plus b cubed. Alright, now let's see if we can simplify this at all. So we just have a cubed. Don't think there's anything we can do there. A squared b, well, right here we have an a squared b and we have an a squared b right here. So that's going to be plus 3a squared b. Here we have 2ab squared. And then a b squared a, these are the same terms, right? B is being squared, a is to the first power. So the variables are the same to the same power as well. So we add the coefficient, so that's plus 3ab squared plus b cubed. Okay. So why might it be useful? We could also do the same thing, we could also do the same thing for a minus b cubed. And we would get something similar, right? We could find a pattern. So why might this be useful to know all these patterns that we just solved for? So it's useful because as we keep going, it's kind of annoying to have to multiply every single binomial together, right? To multiply one binomial with another binomial, with another and another and another, it just takes up a lot of time. So if we know the patterns, then we can, I think of it as we can create shortcuts. Just like what we did up here. We were able to bypass the multiplication part and then just plug in the what we have. So we can create shortcuts, save time, skip past multiplication. Alright, so we can sum up everything that we just learned into this table up here, okay? So there already are names for this. So there's the sum and difference right here, where you have a binomial that have the same terms but just opposite signs inside, and you can see that it's equal to a squared minus b squared. Over here on the right side are examples. Okay, so then there's the squaring of a binomial. You can square a binomial with it being positive inside, and square a binomial with it being negative inside, and these are the results. These are examples. So, and then you could also do the same thing with cubing a binomial, and we already found this one just up above, and this is what it would look like if you were to subtract them. Okay, so again, because we can figure out these patterns right here, we can use examples like this and just plug in the z and the 3 or the m and the 2. We can plug these into the appropriate spots here and save a lot of time and skip past multiplying them. Okay, so to elaborate, let me ask you this. Do you think that there are patterns if we were to quad a binomial? So let's say if we had a plus b to the 4th. Do you think that we could find that? How about if we were to do a plus b to the 5th? A plus b to the 6th? What about to the nth power? Can we just find something to the nth power? Would you even like to try that? I don't think you would like to try that. We'd be multiplying forever, right? So no, I don't want to try that. Well, luckily for us, somebody already went through the troubles and actually found a pattern. And we call this pattern Pascal's triangle. So right here is the degree to which the binomial is being multiplied, the power. Okay, and someone already went through the trouble and found out all of this right here. So this is up to the 5th power, but you could actually keep going. And then this right here, Pascal's triangle, tells you the coefficients that are in front of your variables. So 1, 2, and 1. 1, 2, and 1. 1, 3, 3, and 1. 1, 3, 3, and 1. So we already went through and actually found everything up to the 3rd power right here. So this is the 4th power, where you'd have 1a to the 4th, and then yada yada yada. So let's see if we can recognize any patterns in the triangles above. So let's look at Pascal's triangle first. Okay? Do you guys notice any patterns? I notice right here, these are all 1s, right? And right here, these are all 1s. So the coefficients on the end are 1. And you can see that here. 1, 1, 1, 1, 1, 1, and down here. So you can see that. Now let's look at the coefficients that are in the middle of the triangle. So what do you notice about this right here? And let me add this triangle, this upside down triangle right here. Notice that the 2 is the sum of these two numbers above it. 1 plus 1 is 2. Okay, let's look at this 3. Let's do the same thing. Let's look at the two numbers that are above it. 1 plus 2 is 3. 1 plus 2 is 3. So do you notice that each number on the inside is just the sum of the two numbers above it? Do you guys see that pattern? So there is a pattern for even the coefficients of these right here. So if we wanted to continue on this pattern right here, this would be 1, and then we would have this number right here, which would be the sum of 1 and 5, which would be 6, 5 and 10, which would be 15, 10 and 10, which would be 20, 15, 6, and then 1. Okay, so you could actually keep this triangle going just by using that right there. And now let's look at, so that's the first pattern, is that each number inside is the sum of the two numbers above it. Okay, so that's one pattern. Now let's look at the binomial expansion, this triangle right here. So the only difference between this one is that we have the variables right here. So do we notice anything about the variables? So let's look at the second row. Notice here that it goes from being a squared to a and b to b squared. Now to the next one, it's a cubed, a squared b, a b squared, b cubed. So you notice here that we start with the a being squared and ending with the b being squared. The a being cubed, the b being cubed, a to the fourth, b to the fourth, a to the fifth, b to the fourth. And in between them, you have this is a cubed, then it goes to a squared to a. And if you were to reverse the order on the other side, this is b cubed to b squared to b to nothing, right? So basically what we're saying is that the variables a and b, a goes from starting from the fourth and it descends all the way to 0, and then b on the other end starts on this side being raised to the fourth power and ends up being to the third, to the second, to the first, to nothing. Right there. So that is also a pattern. So the variables a and b let's say the power of variables a and b, the powers of variables a and b, you could say like transfer. Or notice here that this is to the fourth power right here, right? Notice that the sum of the powers between a and b, so a and b, a has the power of 3, b has the power of 1, the sum of those is equal to 4. A squared, that's 2 and 2, that's equal to 4. And then again, 1 and 3, that's equal to 4. So the sum of the powers of a and b cannot exceed the degree of the polynomial. And actually their sum will equal the degree of the polynomial. So right here, that's a to the fourth and b, so that's 4 and 1, so that's the fifth power, which is the power of this polynomial. So the sum of the powers of a and b equal the power of the polynomial. Alright. Now, going through this part, let's try and just to apply our knowledge. Let's try to evaluate some of these. So, we have x squared. Well, let's go to E and F. I'll do these ones for examples for you. So we already know the pattern. This is a binomial and it's being cubed, right? So we can go up here, a plus b cubed, we know that it's going to be a cubed. It's going to be a cubed plus 3a squared b plus 3b a b squared plus b cubed. I think I wrote that down right. Plus b cubed plus b cubed. Yep. Okay. So in this case, though, a is equivalent to negative 2x and b is equivalent to 3. So I can use that. So instead of a, I'm going to write, this is going to be negative 2x cubed. Make sure you use your parentheses. That's very important that you use parentheses. Plus 3 times by negative 2x squared. And then b, which is 3 times by 3. Plus 3 times by a, which is negative 2x. 3 squared plus 3 cubed. And then we just need to simplify. So that's negative 2x cubed. So that's going to be negative 2. That means the negative 2 and the x are being cubed. So it's going to be negative 8x cubed plus, so that's going to be right here. Negative 2x is being squared, so the negative 2 and the x are being squared. Negative 2 squared is 4 times by 3 times by 3. So that's 9 times by 4, which is 36 x squared. And then on over here we have 3 and negative 2x. And then 3 is being squared. 3 squared is 9. 9 times by 3 is 27. 27 times negative 2 is, let's see, so wait, that's going to be negative 6, so that's going to be 3, that's 27 times by 2, 27, 27, that's going to be 54. So that's going to be subtract 54. Subtract 54x. And then for the last term, it's just going to be plus 27. So there you go. All we had to do was plug in the terms to get our answer. Now let me go ahead and move this to the side so I have room to do the other example. So let's do f. So I have 3x to minus 5, and that's being cubed. So that's actually going to be up here in this table. This is the cube of a binomial, so that's a minus 3. Notice that in Pascal's triangle, they're all addition. But now we are subtracting. So that's going to be a cubed minus 3a squared b plus 3ab squared minus b cubed. So I'm going to write down my equation. So that's a cubed minus 3a squared b plus 3ab squared minus b cubed. In this case, a is equal to 3x and b is equal to 5. So if I plug those in, so I have 3x cubed. I'm plugging these values into a and b accordingly. Minus 3 times by a, that's 3x squared. And then b is 5. Plus 3 times by a, which is 3x, 5 squared, which is just going to be 25 when I square that. Minus 125, because 5 cubed is 125. So again, the 3 and the x are being cubed, so that's going to be 27x cubed minus the 3 is being squared and the x is being squared, so it's going to be 9 times by 3, which is 27, and 27 times by 5. Let me go ahead and try that in my calculator. 27 times by 5, which is 135 x squared. Now for this term, it's 25 times 3 times 3. It's 25 times by 9, which is plus 225x minus 125. Now I know that this might be a pain, but imagine just trying to use regular multiplication and multiplying every single binomial together three times over. So that's why this is useful. In exercises 4 through 9, find the product. So I'll let you guys do those exercises on your own, but this is what your homework should look like. But I want to get down to right here where we use Pascal's triangle to expand the binomial. Okay, so we have 4t minus 2 to the fourth. So I'll do number 8. So we can use Pascal's triangle and expand the binomial. So this is to the fourth power. So right here we can use the triangle. So we know we should have 1a to the fourth. I'm going to write that down here. So a to the fourth plus 4a cubed p sorry, 4 plus 4a cubed b plus 6a squared b squared plus 4, that should be ab cubed, I believe, plus 4ab cubed. I'm just trying to think of the patterns that we solved earlier, plus b to the fourth. So in this case, a is equal to 4t, b is equal to 2. So let's plug those in. So 4t to the fourth power plus 4 times by 4t cubed times by b plus 6 times by a. A is 4t, so that's being squared, times by b, which is 2, that's being squared, plus 4 times by a, which is 4t, times by b, which is being raised to the third power, plus b, 4t to the fourth power. Okay, now let's simplify. So the 4 and the t are being raised to the fourth power. So 4 to the fourth power should equal 256, I believe. 4 times 4 times 4 times 4. Yep, 256 t to the fourth power. Now I have in the next term 4t being cubed. So that's going to be 4 times 4 times 4. So that's 64 times by 4, which again is 256. And then that's being times by 2. So that should be plus 512. And then the t was being cubed. T cubed. In the next term, 4 is being squared, t is being squared. So that's 16 times by 6. And then times by 4. So 384t squared. Okay, in this case I have 2 being cubed. So that's 8 times by 4 times by 4. So 8 times 16, which is equal to plus 128. And then we have a t multiplied by t. Plus, and then 4 to the fourth, and wait a minute. I actually wrote that term wrong. b is 2, so plus 2 to the fourth power. So that should be 64, I think. So 2, nope, that should be 2 times 2 times 2 times 2, that's 16, plus 16. So there you go. I just used the binomial expansion, the Pascal's triangle, to find the product of this right here, instead of actually doing 4t minus 2 times by 4t minus 2 times by 4t minus 2 times by 4t minus 2. And that would have been a lot harder process. Alright, so today's lesson might have been long. I apologize for that. So hopefully you found it useful though, and it refreshed your memory on how to multiply. But the big takeaway is trying to use Pascal's triangle and using the patterns to avoid having to multiply the binomials at all, right? So I won't be seeing my Thursday class. So if you guys have questions, please come and see me in class. Maybe Monday, Tuesday, or Wednesday. If you have questions on this, if you're able to watch it before then, and I can explain it further there. But yeah, hopefully you guys have a good fall break, and I'll see you in class.